Here's a video for the Unit 7 practice test getting ready for types of reactions and balancing reactions and tracking energy of reactions. The first part, I'm going to have you balance two of them on the test that require you to draw a diagram. It really doesn't matter which order you draw your diagram. You could balance this your usual way and then draw diagrams, or you could draw diagrams and then balance it some other way. But it does need a diagram. Underneath there, it isn't just going to be just counted things. It should have particle diagrams, little circles are representing them. So I'm going to just start balancing it using a diagram. I'm going to draw an N tied to an O, because that's what that shows. That gets added to an O2, so I'm going to have an O tied to an O. So that's what that shows. And that's going to make an N with two O's attached to it. That's how I'm going to put them symmetrically, but you could write NOO or OON. When I count this up, I see that there are 1, 2, 3 oxygens over there, but only 1, 2 over there. So I can't start with 3 and end up with 2. So I know I'm going to need another one of these. Now I do have 4. But what I need to do, like I have 4 on the right side, but I only now have 3 on the left side. That's okay because I also have 2 N's on the right. I'm going to come over here and make another N and another O. Now when I count it all up, I see 2 N's on the left, 2 N's on the right. And I see 4 O's on the left and 4 O's on the right. That's balanced. I drew 2 of those. There's only 1 of those. I don't need that, but I can put it in there. And there's 2 of those. That I used a diagram to balance it. This way I'll do it another way, and then I'll regroup, and I'm going to count the FEs and CLs, FEs and CLs. Now I'm going to have to erase this, so if you're doing it this way, you got to be prepared because you're going to need to draw particle diagrams. I only see 1 of those and 2 of those, but over here I see 1 and 3. This is the classic 2-3 dilemma with the chlorines, but it's pretty darn easy. If they're only found in one spot, if I have 2 on one side, 3 on the other, I need to triple this to make 6, and I need to double this to make 6, because that's the only thing that both of them go into. But once I did this one over here, I got to recount. That means that there's 2 FEs, so I put a 2 right here, 2 FEs, so that I get a balance. Now it's balanced, 2,6 versus 2,6, but those are not particle diagrams. That's just a count. It says to draw an FE and an FE. Draw 3 CL2s, CL tied to a CL, CL tied to a CL, and another CL tied to a CL. And finally, draw FeCl3s. I'm envisioning those maybe as an FE and then a 1, 2, 3 dots around it. That's one of them, and I'm drawing another one, FE with 1, 2, 3. That's a particle diagram. That's what's necessary for this. Next section is balancing the following chemical reactions. I'll get me a little piece of scrap paper so I have room and it covers it up a little. Alright, different strategies. This first one, I can see that that is a combustion. Carbons, hydrogens, and oxygens. They work pretty darn typically the same way every time. There's just 1 or 2 little tricks along the way. What I'd suggest is always, always, always do it right in order. First C's, first H's, then O's. I like the little chart like this so I can compare side to side. I see 3, 8, 2 versus 1, 2, and then I see 2 of these and 1 of these. That equals 3. First thing I'm going to do is fix the C's. If I have 3 on the left, I need a 3 on the right. That'll fix them. Don't even count the oxygens yet. Let's just wait. Next thing I do is I fix the H's. If I have 8 on the left side, I'm going to need 8 on the right side, so I 4 times that, and I fix those to get 8. Now count the oxygens. 3 times 2 is 6, plus 4 is 10. There should be something we can write right there that fixes everything if we do it in order. I have 10 on the right, only 2 on the left, but they come in pairs, so a 5 there will make that balanced. That one is done. I don't need to put anything in front of the C3H8. Next one, When I see one of these, this is a double replacement. It's all ionics. There are 4 ionics. I am not going to count everything like O's and H's separate. I'm going to keep the SRs, the OHs, the FEs, and the CLs. I'm going to keep those OHs together because they showed up the same over here as over here. SRs, OHs, FEs, CLs. Next trick is I always write the right side the exact same way as I do the left so that I can easily compare. I see one of those, 2 of those, 1 of those, and 3 of those. 1 of those, 2 chlorines, those are down here. 1 iron, those are here, and 3 OHs. The strontiums already match so far. The OHs do not. I have the classic 2-3 dilemma with OHs, so I'm probably going to need 6 on each side. So if I triple this, that will give me 6 of those, but now I also have 3 of those, and that's okay. And I double this side, so I get 3 times 2 is 6 OHs over here, but now I have 2 FEs. Okay, so I fixed one thing, but now what doesn't matter? Well, I just start at the beginning, 3 versus 1. Apparently I need to triple my amount of strontiums on the right side. Triple it. I put a 3 here. Recount it. That also changed my chlorine to 3 times 2 is 6. 3, 6, 1, 3 versus 3, 6, 2, 6. Okay, my 1, 3 doesn't matter, and they're together. I need to double both of those, the FEs and the CLs. I do that, I'll get 2, 6, 3, 6, 2, 6, 3, 6, 2, 6. That one is done. Down to the next one, 5, another combustion. This one, also a complete combustion. It's got C's, H's, and O's. Always, always, always just do them right in order. First the C's, then the H's, then the O's. I see 6, 6, and 2 versus 1. I see 2 of these so far, and 2 plus 1 is 3 oxygens. First, fix the carbons. Put a 6 here. Fix that. Don't recount yet, because we're going to mess with the hydrogens. Now fix the hydrogens. I need to triple that. Put a 3 there. That's now 6. Now recount the oxygens on this side. 6 times 2 is 12, plus 3 is 15. Okay, here's one of them dilemmas, and it's easy enough one to deal with. When you get to the end of your C's and H's, when you count your O's, if one of these numbers is even and the other is odd, then there's really nothing you can write on that line that's going to make it work unless we wrote a half number. So I talked about this trick. Double everything. When they end up one odd, one even at the oxygens, double everything except the oxygen. We're still saving that for last. We'll figure out what to write there. So I'm going to go back up over here. Apparently I'm going to need 2 of those. I'm not going to need 6 of these. I'm going to need 12 of those. That's twice as much. I'm not going to need 3 of these. It's going to be 6. I could go count everything, but I don't need to. I doubled everything, so the ratio should still be the same. Now I'm going to recount my oxygens. On this side, I still have 2. On this side, I now have 2 times 2 is 4, plus 6. I have 10. Now they're both even. So when I go back up to here, what can I write there that'll balance it? A 5. That'll change that to 10. That is now balanced. Moving down, H2SO4. Okay, another trick one. It's a double replacement. Those are all ionic compounds, kind of. That doesn't technically look like an ionic compound, but we can pretend it is. The trick with practice is you realize you'll count H's, SO4s, because that's what I'm seeing up here, BAs, and OHs. So on this side, I'm going to do H's, SO4s, BAs, and OHs, and I like to write them in the same order, even though they came in a different order. Here's a little then way of looking at this. I don't have to scribble this out, but it might help you to visualize H's and OHs. That's kind of what a water is. It's kind of ionic and kind of molecular. Count up. I see 2 of those, 1 of those, 1 of those, and 2 of those. Over here, I only see 1 H, that one. I know you're seeing another H, but that's in part of the OH. I see 1 OH. I see one BA and one SO4. So when I go down the line, 2112 versus 1111, well, I need to double a couple of things on the right-hand side. I need to double my H's and OH's. So those are really just the waters, the H's and the OH's. So I need twice as many of those. That'll turn that to 2 and that to 2. And now that's balanced. That's it. Is all it took is just what that 2 in front of that. Number 7, once again, I'm loving throwing some combustions at you. C's, H's, and O's. Once again, I will go right in order. First the C's, then the H's, then the O's. I see 2, 2, 2, but I only see 1, I see 3, and 2. First, fix the carbons. Double that. Don't even recount the oxygens. Oh wait, now the hydrogens are already fixed. They're already matching. So now it is time to recount. I see 4 there, plus 1 more, 5. There it is again, the classic odd, even. There's nothing you can write there that would get the job done. Well, you could. You could write 2.5, and then when we balance that out, it would be 5. But you can't have 2.5, so you'd have to double everything. But that's kind of the trick that I was trying to teach you is when I see odd even or even odd, double everything. Except for the oxygen. Save that for last. Double everything, except O2. What does that look like? I need 2 of those. I need 4 of those, and I need 2 of those. I don't have to recount the C's and H's. I could, but what I really need to do is recount the oxygens. I just changed the oxygens. 4 times 2 is 8, plus 2 is 10. Now I can see that it just takes a 5 right there. Very similar to one that we already saw. I think I'll wrap up and make a new video for the next.